Hello friends, you're most welcome in this lecture number 10.5. This is the part of CS Duty Physics Learn with me lectures on some special topics, and today's topic is the solid state laser, and here I will include another solid state laser, that is Nd YAG laser. I, Dr. Mohan Verma from Department of Applied Physics, Sri Shankaracharya Technical Campus, Bhulai. Outlines, the objectives and the prerequisites of lecture, different types of laser, and the introduction of Nd YAG laser, then the basic components of this laser, Nd YAG laser, the structure form, and Nd YAG the working principle by using that 4-level system, and its limitations and applications, and finally the summary of the lecture as usual. Objectives: to discuss the construction and working principle of Nd YAG laser along with some important applications, and I expect my student as a prerequisite to understand this lecture, they must have the knowledge of fundamental mechanism of laser, and the knowledge of 4-level pumping scheme and basic components of laser system. So on the depends on active material, lasers are classified into 4 parts: the solid state laser, which is further classified into rupee laser and Nd YAG laser, and the gaseous laser, the carbon dioxide laser and helium neon laser, and semiconductor laser, that gallium arsenide and gallium phosphorus arsenide. So these are fundamental classification of laser, out of which in these lectures I will discuss about this Nd YAG laser, the solid state laser. So the introduction of this Nd YAG laser, this is the short form used for neodymium doped yttrium aluminum garnet. Nd ion is a rare earth metal and it is doped with solid state host crystal like yttrium aluminum garnet, and the chemical formula is just Y3Al5O12 to form Nd YAG laser. Due to doping, yttrium ions get replaced by Nd3 positive ions. Also the doping concentration is around 0.725%. So in the first case, in the case of rupee laser, that is very simple, that was too less, that is 0.05%, but here that doping concentration is slightly more than that one, and that is 0.725% by weight. It is a solid state laser with a 4-level lasing system. Neodymium YAG is Nd YAG is used to produce high power, and such lasers have been constructed to produce over a kilowatt of continuous laser power at 10.65 mm, that is actually in IR range, infrared region, and can achieve extremely high power in a pulsed mode. This is also in the pulse mode, just like that ruby laser. So the basic components, so these are the usual basic components of a simple laser system. There must be one active centers, active medium, pumping techniques to pump atoms, and optical cavity to oscillate those atoms before final formation of laser, and a pumping scheme. So in order to explain the mechanism of this laser, we will use the 4-level system. So the active centers are neodymium ion, Nd3 positive ions, and active medium is Y3Al5O12, that is yttrium aluminum garnet, and pumping techniques. So here the krypton arc lamp is used to pump ions from one energy level to another energy level, and optical cavity is that fabricated resonator. These are just the combination of 2 mirrors sandwiched that active medium and active centers. So the structure is, this is the basic schematic diagram of that Nd YAG laser. So this is that krypton lamp to pump that ions, and this is the Nd YAG rod. So this portion is partially polished, and this portion is 100% polished. So the fabricated resonator is stabilized here. So the working substance, that is the active medium, that is the yttrium aluminum garnet. It is transparent and colorless, so there is no need of a transparent container to contain this. And then these Nd3 positive ions are replaced, and this replaces Y3 ions in this active medium, which makes population inversion. So this Nd3 positive replaces Y3 positive ions in the active medium, which makes population inversion possible. And here this obviously these Nd3 positive ions are active centers, which will transit from one energy level to another energy level. The resonance cavity is here that fabriferous resonator. It is made by silvering and polishing the end of laser rod and YAG rod and considered the optical resonator. Fully reflected plates at the left and the partially reflected plates at the right, both optically plane and accurately parallel. And this krypton arc lamp is used as a pumping technique here to pump atoms. So working principle, this is a 4-level system. So Nd3 positive ions are excited to pump bands by absorbing the white light of the wavelength 5000 angstrom to 8000 angstrom of this argon arc lamp. So this is the ground state where initially that Nd ions are there. This is the second energy level, and the E3 that metastable levels, and these are the higher energy level. So from there they rapidly decay to metastable state E3. So by absorbing the energy, Nd ions optically pumped to higher energy level E4, and through a non-radiative transition these Nd ions accumulate here on this E3, the metastable level, through non-radiative transition, and there is some probability of spontaneous transition also. And the population inversion condition is now maintained in between this E3 and E2. So initially this is almost empty, so the population inversion condition is maintained here. And when one external photon is given to the atoms of this ions of this E3 levels, which has been fulfilled that population inversion condition, that stimulated transition starts, and through this chain reaction we get the laser in the infrared region, and the wavelength of this laser is 10,600 angstrom. So that finally that Nd ions reach to the ground level in a non-radiative transition. So that cyclic process continues, and we get that Nd YAG laser. Limitations: the efficiency of Nd YAG is obviously high with compared to ruby laser, which is 2%, while that in case of ruby laser it's only 1%, but still it is very less. So this is one of the efficiency and deficiency. And also this Nd YAG laser is a pulse form laser, and some main applications of this Nd YAG laser, these are used in military application to find the desired target. This type of laser also find application in medical field in surgical purpose, and this is actually high energy laser, high power laser. So this is also used in welding and cutting of steels and communication system. So as a summary, in this lecture the construction and working principle of solid state laser Nd YAG was discussed in detail. Some limitations and many applications were also mentioned at the last. Thank you very much.